So today's topic is digital twin. It's one of the advanced topic nowadays and one of the growing market, and it will be grow for next probably 50 to 100 years. And digital twin is basically coming with two words, digital and twin. So let's understand what is twin first. So twins are of different types, obviously, but one of the twin is called identical twin. So identical twins mostly coming from a same egg, and they are fertilized and created identical um, genomes, we call them, and they are basically with same sex and same features. So this phenomena is available with the animals, with the humans, and all these living stuff. Okay, so twins are very common in nature. But when I talk about definition for twin from a common perspective, so the twins can be like in different type of fruits like cherries and other stuff, and the twins are can possible for the objects, like you can see these babies are twins, they are biological twins. But these two scooters are objects which are twins because they are identical. These two buildings are twins. So basically, if we put the definition a twin, which would be the common for all kind of objects, so we can say pair of objects who are the result of developing from a similar format with identical measurements, are alike in all genetic characteristics and typically very similar in appearance and behavior. Okay, so we can say they are twin. Now the question arises, what do you mean by digital? So digital is a very popular word these days, and its basic definition is very clear. The basic definition of any digital is anything which can be present in the form of digits, such as 0 and 1. So otherwise we can say data and represented. So if it is converted into 0, 1 in a data format and represented, then we can say that is a digital. Example, so you have a notepad previously. Currently, your notepad is in your mobile. You have a clock. That clock is converted in a digital clock into your mobile. You have calendar, letter, message box, calculator, radio, music player, all are converted into a digital form into your mobile. Now that is sitting on your mobile apps. Okay. So that means we converted them digitally, and that replace your physical stuff. Okay. So when we talk about digital twin, okay, now what exactly we want to create a digital? Anything what we exactly need to create a digitally. So let's consider a calendar. So first the feature of the object, and mostly in technically we call the parameters. So the features of the twin calendar. So we understand what are the parameters. Okay. So we understand there will be a calendar which represents the days and the months. Then processes or practices followed by that object. Now, which type of calendar? It's a lunar calendar, solar calendar, any like Hindu calendar, Georgian calendar. So different types of calendar. And each calendar has their own rules or behavior. Like lunar calendar follow 29 days. Solar calendar follow each month of different period. 30 days, 31 days, 28 days. Then how it behave under different circumstances, conditions. Okay. So let's consider if it's a Georgian calendar, so in Feb, there will be 28 days. But in a leap year, it will be 29 days. So conditions are different. If it's a lunar calendar, in every 3 years, there is one extra month added into the calendar. So those kind of conditions we need to understand, and how this digital stuff will behave. Intelligence of the object. Is the object is intelligence? Yeah, the calendar should be intelligent. It should be represent the numbers, the values, the days, and it also can represent the holidays, the working days, the festivals. So those kind of knowledge base we need. Influence of other objects. Is this lunar calendar can be influenced by others? Answer is yes, it can. It can be influenced by others. Then influence by other objects. So like if you know the Georgian calendar changed many times. Now you are following the month starting from January, but January and February were in the 11th and 12th months. But with time, they they are the first and second month. Okay, so like that, all these changes happening, and um, because of the influence of the power, influence of the practices, capacity and volume. Capacity and volume is basically, if I'll take the calendar example, it should have the capacity to store at least 1 year. If it is having more volume, it can store for 10 years, 100 years, 1,000 years. Depending on the uh, memory, depending on the availability of the resources, we can enhance the capacity and volume. But the minimum capacity and volume we cannot change. So the minimum size should be there, and we can enhance based on the different requirement. Releasing and changes, relearning and changes. Relearning and changes means if tomorrow it will happen that there will be new holiday added into your calendar. Let it be somebody bring the 27th of every month going to be holiday. So in that case, your calendar need to get updated. That need to be changed, and your digital version of that calendar need to be updated. So those relearning and changes should be adaptable. Then unknown parameters. Unknown parameters, randomly something will come. You don't know, but still it is. It should be there unknown parameters. Like there is some cyclone and one day is declared as holiday. Unknown parameter. So anything which we need to convert into digitally, we need to identify these things: parameters, behavior, conditions, knowledge base, biases, size, updates, and unknowns. So if you know these things of a particular object, it's easy to convert them into a digital format. Okay. So once we get that, what they are doing? So what exactly we are doing to converting a physical thing into a digital thing? When there is a replica of a physical thing converted into a digital format, we call them a digital twin. So like here, there is an aircraft engine. Now these days in India, people are trying to develop the aircraft engine for a long time, like it's almost 35 years, but still we are in a development stage. So what exactly it is happening? So like there's a very big company called GE, General Electronics. They are using digital twins to identify the parameters. They do the testing based on that, and they created a digital twin of the aircraft engine. So that is very helpful and useful for them. So what exactly they created? They take all the parameters and everything what we discuss and create it in the system digitally. So definition of a digital twin refer to a computerized companions of physical asset that can be used for various purposes like recreation, testing, monitoring. Many things can be possible through digital twin. So similarly, these days, most of these big buildings, okay, they create a digital twin of its own building to maintain, monitor, recreate like that. So that's a very common phenomena these days. So from the building perspective, we can say digital twins use data from sensor installed on physical objects, okay, to update the representation of the reality based on a mathematical and statistical model. So if you get all the information, you have to represent that model in a mathematical and statistical form in the system, then we call them a digital twin. So that is the definition. Any question on the digital twin definition? I hope it is clear. We are creating a digital replica of a physical stuff. That means the physical stuff is there and we are creating a digital stuff. As they are identical in nature, we call them digital twin. But in naturally, the physical twins are different. They are physically equal. But digital twin is means one is really existing, which is your physical uh, reference, and then we are creating a digital reference of the real object. And when we create this, we call a digital twin. Now, the question arises how to gather the data. Okay. Now, when the question arises how to gather the data to create the digital twin, so the solution come in the model world with a name called IoT. And the IoT is known as Internet of Things. IoT describes the network of physical objects or things that are embedded with sensors, softwares, and other technology for the purpose of connecting and exchanging the data with other devices. So when I'm saying other devices, that means it will send the data to a system to store the data and system over internet. So it may be Wi-Fi connectivity, it may be physical connectivity, any connectivity, but it can sense the data and send the data to a centralized location or to a system. Okay. Sometimes the definition over the internet is not perfect because it can be sent within a one network, wide area network, or within a personal network. So you can say over the network, not internet. So in that case, the definition changed and it should be the system which will able to exchange the data over a specific network. We call that IoT. Instead of IoT, ION, you can say. Internet of the Things, no, NOT. Okay, network of things. So if you have a network and in that network you have all the devices, like mostly the sensors, the cameras, the digital locators, the heat sinks, everything. So then, and you are sending the data to a centralized system through a network, then you are able to gather the data for your digital twin. So let's take a landscape of how the IoT work. So the IoT has different bodies, part. So like if it is within a human being, we call that body area network. It is called BAN. If it is bit far, like within that personal area, so within a room or something, we call body sensor network. Okay, which is within a car, within a house, within a room, like that. But if it is within your boundary, within your house, we call that bit, it is enhanced bit more area, and it become home area network. Your personal area network move till the home area network. Now, if it is more connected, like your nearby, because you are getting all the utility facilities from your society, so near area network, then it is enhanced to all the service provider and whatever is there. So we can say that is a wide area network. And if this network is engaged with the different states, you can say global area network or not a global area network, you can say wide area network. And if it is interconnected with all different satellites, which is not on the Earth, then you can say global area network. So this is how the IoT landscapes is now enhancing itself. Probably going forward, we can monitor the Earth from different planets and we can send that data to our planet to monitor, to understand this stuff. So this Landscapes of IoTs are helpful for us to gather the data. So when we gather the data, what are the types of the data of a any physical object? The data are of different types. Mostly we divided into 8 types. So one is like your external data, then internal data, okay, process data, historical data. Now here, when I say process data, external, internal data, if you consider a human body and we need to create a digital twin of a human body, then external data like whatever the features, your height, your weight, your eye color, your hair color, your skin color, uh, all this stuff would be the external data. So that will be get from a, you can say, camera, from the high resolution camera. Internal data like your blood pressure, your artery flows, your heartbeats, um, your brain capacity or ability to execute the processes. So those are internal data. So how you will get? So if we put some sensors, some device on your hand or in your body, then we can get the internal data. Process data. So like when you are eating, when you are jogging, when you are looking somebody, when you are analyzing something, when you are studying. So all these are during the action, and during the action, your body, how it behaves. So that is the process data. So during the process, during the action, how all these base data changed. Okay, now when I'm saying the base data, so it is like your blood, your bones, all those stuff are the base data. Bone density, blood group, how many RHS groups are there, what is the red cells and white cells are there, all are base data. Then historical data. Historical data, like if you have, if a human has some medical issues, and how he gone through all the emotional traumas in his life or in her life, how he reacted previously. So all those called as historical data. So because from there we can understand how he will or she will behave in future. Transactional data. Transactional data is day-to-day activities. When he communicate, when he express. So what would be the stuff? Um, Analytical data. Analytical data, and it will come through the biases. So all the data when we collect, after collecting all the data, human beings relearn it. So let it be. Some days back we learned that there are 9 planets uh, moving around the sun. But after some days, it was happened that no, Pluto is not an planet. We call that not a planet. So not a planet. So now the number of planets are 8. So your mind relearned that, and now you are saying that there are 8 planets moving around the sun. Then they re-update the information and they say, no. Pluto is a planet, but it's not a complete planet. It's a dwarf planet. So we say that there is 8.5 planet is moving around the sun. Now your mind analytically update that. Then there is a simulation data. Simulation data uh, when you are climbing a tree, when you are climbing steps, when you are walking. So every time your mind do simulation. How? Because your senses, whatever you are collecting the information, based on there, it will ask your body where to put the step, what would be the height, what would be the length, how far you should go, what is the best way to put the step forward. So now those things are happening inside your brain, that simulation, and then your body is reacting based on the instruction of your brain. So that is your simulation data. And exactly these type of data we can collect from any object, which are very critical in nature. And we can use those data to understand what exactly the digital twin is doing. Let's take a case study. So the case study of a building. So let's consider this is a physical space which is represented in a 2D picture. Okay. And we have all the information about that physical building. And that physical building twin we need to replicate, or a digital twin we need to create. Okay. And now to create that, we need sensors, digital devices, and allocation and installations of those sensors and digital devices across the building. So let's consider we need to monitor the building from the outside for the external data. So we have to put lot many cameras which will scan from starting to end and always update the data. Okay, so if it will scan, then the data will reflect in our system. So we need to scan very detailed, very minutely. So the number of cameras will be increased. Okay, so we can scan and we can update the data, and based on that data, we can update our digital twin. Similarly, if there is any vibration, if the building is holding uh, any kind of issues. So what we do, we put sensors. Every place there will be sensors. What is the temperature? What is the pressure? How much is the what we call moisture is there? So those informations we put sensors there. So vibrations and position of those sensor, temperature, pressure, stress. Okay, all those things we can capture. All these things we can capture from sensors, from cameras, and from other devices. Apart from that, we have base information. Base information means what are the architecture of this building? Because initially the architecture is developed, then only the building developed. What are the materials we used? What are the uh, combinations of material we use? Okay, all these information we put it together. Then we check the historical data during the building construction. Is there um, anything happen during the installation? Something happened. All those things we need to capture. Where is the fire exits? And how many times it get open? What are the door structure? What are the heat value it can handle? So all this data will put. Then hypothetical data also you put. Hypothetical data, let it be there is some function going to happen and the building capacity is holding up to 5,000 people. But on that day, 50,000 people come into the building. So is the building capable enough to hold? Let's consider the power is not there and how the cameras and the sensor will work. Okay, all these hypothetical data will update. Then simulation of the data. We do simulation for future perspective. Let's there is a earthquake happen, how the building will take that. If there is any lightning happen on the building, how it will take. If there is a blast happen nearby the building, so everything we consider and simulate them. So basically, what we did, we have a physical asset, we have a digital twin asset in our system. We collect all the information, put them into a platform, you can say IoT platform. And through the IoT platform, we put them into a cloud platform. In a database platform that may be a cloud. And there we do all the analysis, okay, to understand the building. And when the building is growing, like with time, means with time the usage will happen of that building and how the observation of the moisture, temperature, pressure, uh, so all those things will be captured. And every day the analytical system will compare the previous day picture, current day picture, previous day pressure, current day pressure. So through that we create a statistical model, and based on that our digital twin behave. So practically Your physical building, whatever it is doing, the digital twin also doing exactly the same. The raw data are coming from the sensors, from the cameras, from different sources, and we put them together. So let it be. What is the benefit by spending so much money on creation of a digital twin? So the benefits are so high. Okay. Now, what is the process to create a digital twin? So stages to create a digital twin is first stage is called connect and collect. So as we discussed during the discussion, we first understand the building, and then we understand how we can connect the sensors, install the devices, and then we can collect the data. So first objective is to collect the data. Once we collect the data, we put them together and learn the data and analyze the data. Once we learn and analyze, after that, the next stage is alert and advise. Let it be there is some cracks happen in some area. Let it be in floor 18, there is a crack happen. It has a impact on the building. And our camera is taking the picture every day. And the sensor understand there is some crack happen. So the alert and advice automatically get regenerated, sent to the uh, whoever is looking after physically, and then it will be optimized or removed. Okay. Or the decision can be taken if the crack is very serious, it will impact, and that impact or the seriousness will become from the simulation without spending lot of money. We can do that by simulating the twin. Innovation and transformation is easier. Innovation and transformation means let it be we observe the building details and everybody is appreciating. We need to create another building similar to that. Then obviously we can use that same structure, that same twin for architectural perspective, for other perspective, and transfer that to a new physical body. So from there, you understand there are 3D printing concepts are there. So all these things are possible through digital twin, and the stages are five: connect and collect, learn, analyze, alert and advise, decide and optimize, innovate and transfer. Okay. So benefits, what are the benefits out of digital twin? So you can sit in a office, you can observe the building. You need not to go each stage. Like previously what happened, there is a person who is called the office uh, manager. Okay. He has the basic logistic manager. He has to go each place of the building, and then the security team. They have to move everywhere to check the safety of that building. Okay. And they do inspection every 15 days or any 30 days. Okay. Now, all these manpower can be saved. You, you put everything, all the sensors, all the cameras, integrated that to the cloud, and you get all the analysis report sitting on your desk. Even if you want to go a tour, you can put a VR or AR camera and you can go physically inside the building, like not physically, but you feel that you are traveling inside the building. Okay. So first thing, predict performance, how the building is working, monitoring you can do. Verify the design choices. If there is any enhancement required, so you can do the enhancement, not by creating the other models or so much pictures, other stuff, but just by simulation, you can add on the new changes. Product meets expectations. What is your expectations? How is the product behaving? Everything you can say. Avoid the failures, obviously, because you understand before the time that what is going to happen through the simulation, through the analysis. Reduce the risk. Obviously, that will reduce your risk. But the digital twins help quick design replications as well. Like first you create one building and you didn't like, you start to create another building with more precise and more developed scenario. So you can do that. It also helpful to do the quick scenario testing. Like I gave one example, a building which holds 5,000 people, but someday it it have a function and there will be 50,000 people, how it will hold? So test scenarios. It also helpful for the add-on and improve the structure based on the requirements and future predictions. So all the benefits are there in digital twin. Now, the areas, okay, major application areas where the digital twin is used right now are manufacturing, automobile, aerospace, healthcare, wind farm. And apart from that, undersea infrastructure, retail, um, and then obviously physical infrastructure is there, oil and gas industry and gas turbine it is. I can say I was working in utility companies, and in utility companies, like infrastructure maintenance is one of the major tasks and one of the major expenses they do. So like you have internet cables. Internet cables are, they are coming through the seas. So one country to another country, there are different internet cables are there. And these cables are most of the time destroyed by any trawler, any sea, or very big whale fishes like that. They destroy these cables. Okay. Now somebody has to go there, okay, to repair those cables. But during that, the major problem is that identify at which place actually it destroyed. Now, if you have a digital twin and the whole tunnel where the cables are going through, that tunnel has all these sensors, all these devices, then you can easily see from your digital twin actually which place the destruction happened. Okay. And you send your crew with the obviously ship, and the crew people will go at that particular place to repair the cable. That will save huge amount of money and effort as well. So these are the very basic example of uses of digital twin. So going apart from those areas, we have automation of ships. Okay, like we create one ship, like and then we replicate that ship to digital transformation and through 3D printing, or you can say 4D printing, and we create a new ship with a very short time period. Remote aircraft towers, these are currently in use. So they estimate when the flights will come, when the flight will be left. So because the flight frequency is very high at this moment across the globe. So they estimate, and based on the estimate and simulation, they'll give a time to the planes when to land, when to take off. So those things are currently happening. Automation of wind farms, remote drilling. Yeah, remote drilling is another very expensive stuff that is currently using digital twin very, you can say vastly, and that is save lot of money of that. So remote drilling like petroleums are mostly we get in between the sea, under the sea. So if there is a digital twin of that area and we can drill based on that information, and that is very cheap. Like in defense also, they are using the seabed twins, and they simulate if there is a submarine going through that, what are the problems going to happen. So digital twins are now in use. But what are the basic requirement? Now I can see we'll disconnect in 2 minutes. So if we'll disconnect, reconnect into the same link. So the basic requirement to do a remarkable digital twin design is first one is high performance processors, because you gather huge amount of data. Now when you gather huge amount of data, to analyze them, you need very high capacity processor which can process all these big data very quick succession. If your Processing speed is slow. You cannot simulate easily. You cannot predict future. You cannot give alert. You cannot provide the advices. Next is big data. Obviously, gathering the data, you need to store the data. And to store the data, you have need a big database. Previously, the data storage is expensive stuff. Currently, with cloud, with other technologies, now the data storage is bit cheaper. That's how the digital twin creation is also now in trend. So you store all the data, then first global networks. Obviously, first global network means your data processing because we are depending on IoT. So the data communication should be very high. So within microseconds, the data should be in your database. Then you can process and simulate. So like there are many systems in defense which is working in microseconds. Third system, anti-missile systems, those are work in microseconds. So as I mentioned, we need a very fast network to, to do remarkable design for digital twins. Then massive storage. Uh, Now big data means that is the database logical part. Storage means physical part. Massive storage, like previously we store uh, into transistors. Now the transistors are also converted into microchips and we are storing the data. And the physical storage should be very high. That means your investment on the infrastructure of storage would be high. Storage is also linked to your batteries, like energy storage, because you need also some kind of external energy because you need to monitor 24 into 7 and you need to capture the data into 24 into 7. So your energy supply should be uninterrupted, and that can be possible if you have a storage energy. Then cloud technology, obviously you are storing the data into cloud. You need cloud technology. Artificial intelligence, yes, for analysis, for prediction. A human being cannot do so quickly, so update and so accurately. So we need the help of artificial intelligence. Advancement of algorithms. Obviously, current algorithm is mostly specific to the classical computer for the single computer. It's not focusing on the parallel processing and quantum processing because when the data will be very high, probably in some days, the classical computer will not able to help or support them. Obviously, the supercomputers are based on the parallel concept of the classical computer, but that will also get failed. So the new concept will become quantum computing. So through quantum computing and through the advancement of the algorithm for the quantum computing and parallel computing, we can achieve remarkable digital design. So what is the roadmap? So you can see the roadmap for this roadmap is for IoT, and IoT is some kind of integrated to the digital twin journey. So the IoT started with RFID, where we put a card like attendance card, and that card will send the RF signal to the nearest sensors, and from there we can understand who are entering into office, who are living in the office. And these RFID cards are useful to perform the surveillance. Then slowly, the process increased and we captured the videos, we have the image processing informations and we use those for surveillance, security, healthcare, transport, food safety, document and management. All these things are happening. And when the time go up, the landscape of the IoT enhanced and we identify the location of the people, everyday objects. We understand what exactly the position of that person, where he is going, how he behave, or what are the objects details, because we are able to identify the information from satellites, from different sources. Then again, we enhance. Then teleoperations are happen. So we are able to control the objects through sensors and control the physical. as well by 2025. Now, what is future then? Now, there is a organization called Roots Analysis, and that organization estimated the digital twin market by 2035. So today we are in 2024, sorry, 2025, and if we see the market is very small at this moment in 2025. Okay. So by 2035, the estimated digital twin market will 240.3 billion, which is very, very high market cap. Okay. So in a year, if you consider the total market size is kind of 4 to 5 trillion, uh, or in a bad day, 1 trillion if you consider. So out of that, 240.3 billion in 2035 is only from digital twin, which is a very big cap actually. Okay. So there is a market for this as well. Who are the players right now doing all this digital twin work? So there is Ansys, Azure, Bose, Cisco, Dassault. Obviously, they create fighter planes. General Electronics, they create the fighter plane engines. IBM, yeah, they have very good monitoring system across the globe. Oracle database, because they have their database and they can have a high storage. Siemens, they produce different products, okay, related to defense till the heavy industries. So all these players are into digital twin market. What next? Are we do all this stuff like this, or is there anything in future? Yes, the future is very different. So maybe by 2050, you will find a digital twin of yours. So we call them human robot twins. So he'll behave like you, talk like you, and whatever you do, he can also do. So you can send him to work instead of you. You can do that. So human robot twins is new future. Human-less fighter planes controlled by humans. So humans may sit at the office and their digital twin will be sit in the fighter plane and they will control that. City digital twins, this is now started almost. So what they are creating, they are replicating the digital form of a city, let it be New York City, and whatever happening in the city and how that city will be more efficient, more good in waste management, less crime, more in energy utility. So all these things are happening. And this will be going to happen almost all the cities going forward, I believe so. Then digital workplace twin. Now, digital workplace twin is a concept. It's still in a conceptual manner that all the offices will create its own twin, and their offices will be in a virtual world, like in like your Facebook, or like there are games are there. So similarly, your workplaces will be there. In that workplace, people's twin will go and work, because at the end of the day, you have to produce the services. So when they control there, automatically in the physical world, something going to be controlled and activated. That can be possible. But it is very much dangerous, because most of the jobs will be gone because their twins will work there. Sports via digital twins or digital stadiums. This is happening nowadays mostly into video games, but it is not realistically happening like your Olympics or other stuff going to happen in digital stadiums, and many more going to happen. So that's how the digital twin is growing. Okay, so I'll give one example. Our Bhubaneswar railway station is the first example of digital twin in Bhubaneswar. So we are creating that twin to observe, okay, whether that platform is efficiently handled. Let's consider you have a digital twin, and that twin has all the features of yours. Going forward, it will going to happen in particularly in the healthcare sector. And before you are getting that disease, okay, your digital twin automatically say that, oh, you are getting the disease because you are having this food, or you are drinking so much, or your lifestyle is like this. So he is just showing your face that you are behaving like that. That's why this body going to be decay in some time. Okay, repair it this by this steps. Will it your save your money from the healthcare or not? Because you have all the sensor inside your body, so you know what your body is going through, and your twin is saying every day you should do this, should do that. Your blood pressure, your cell count, everything going to be monitored through the digital twin. So it is easier to become healthier. Now the digital watches are there, which will count your heartbeat, blood pressure, blood sugar level, everything they are calculating. Going forward, there will be twin, which will also take the internal data, external data, environmental data, circumstantial data, historical data, and give you more detailed or accurate information. Okay. Thanks for your time, and I hope you enjoy this session, and we'll meet again. Thank you. Bye.